In this India Moon video, we are going to cover containers in Python, i.e., data structures that can contain multiple types of data. More specifically, I am talking about lists, tuples, dictionaries, and sets. Let's discuss those. In Python, it is fairly trivial to store a single variable. All you need is a variable name, and then you assign it one value. Let's say the string Bob in this case. It could also be a number, it really doesn't matter. But what if you want to store multiple values inside a single variable? That's where Python's data types come in: lists, tuples, dictionaries, and sets. The first kind of container I want to talk about is a tuple. This one is created with normal parentheses. You need one to open it and one to close it. Inside it, you can add whatever kind of data you want. This could, for example, be a string, an integer, or even another tuple, which could itself contain another tuple. As far as the tuple is concerned, a tuple inside it is just another value, meaning you could have a tuple inside a tuple inside another tuple, all with their own individual values. This would be totally fine. Sometimes this is necessary, but usually not something you want to do because it would be quite messy to work with. But anyway, this is a tuple. Next up, we have a list, which looks very similar compared to a tuple. The only major difference, at least for now, is that we are using square brackets instead of round ones. Other than that, we are still adding individual values separated by a comma, and that's all you need. To summarize, a tuple or a list is created with parentheses or square brackets, and then you have comma-separated values. Now, you might be wondering what's the difference between the two. Well, the key difference is that a tuple cannot be changed. The fancy word for that is it's immutable, meaning once you have a tuple, you cannot change it anymore, whereas for a list, you can easily add or remove values or make changes to basically whatever you want. And that's pretty much it. In practice, when you are using them, they are more or less interchangeable for most occasions. You can use either one of the two, it's totally fine. We will explore that in just a second in a bit more detail. But anyway, first of all, we have to talk about a set. A set is defined by curly brackets, but other than that, we still have comma-separated values, and this could be any kind of value, integers, strings, or any other data type would be perfectly fine. Now, what makes a set unique is that every single entry is unique on its own, meaning any duplicate value inside a set will be removed. There are a few more extra things for a set, but those are a bit more advanced, so I'm not going to worry about them too much. Finally, we have a dictionary, and this one has quite a different data structure. We still have curly brackets like we have for a set, which might be a bit confusing, but the major difference for a dictionary is that it's a collection of key-value pairs. We no longer have individual values, instead, we have what is called a key-value pair. In this case, for example, the name is the key, and Bob is the value. After that, we have a comma separating another key along with another value, and this can continue forever. Both the key and the value could be any kind of data type, at least within some minor limitations. Because of that, it's quite easy to differentiate between a dictionary and a set because ultimately they are quite different, they just share the curly brackets, but that's about it. Dictionaries are what you want to use if you want to have really organized data. It can be incredibly powerful, but also, sometimes, it can be a bit too much work to deal with. But anyway, let's work with all of them in practice. Once again, I am in VS Code, and I want to create a new file. Let's call this one containers.py. After that, I can go into full screen mode so we don't have any distractions, and let's start with some basic data types. I want to, for example, create a tuple. To create this one, I need basic parentheses, and in there, I can add any kind of value. This could, for example, be 1, 2, 3. It could also be a string. So, quotation marks, then a string. And that's the basics of it. If I now print a tuple and run the code, we can see that we have a list of items. In just a bit, we are also going to learn how to pick one item from that, but that's going to come later. Next up, I want to create a list. This one works in basically the same way, The only difference is now that we need square brackets where we can add the exact same values, 1 to 3, and a string. If I print this one, print a list, and run the code, we can see we have the output of a list, which is looking very similar compared to a tuple. On top of that, you can also use a couple of functions along with both lists and tuples. For example, what you could be doing is place either a list or tuple inside of the lay function. Then run the code again, and we get the number of items inside of the list, in this case, 4. This would work with a list and a tuple perfectly fine. I can run the code again, and we once again get 4. Perfect. What you can also do with a list is append another value. This happens with the append method. This method wants to have a single argument, which could be whatever value you want to append. Let's say I want to add the string another word. After we have that, we can print a list once more, run the code, and now we get the list with another word at the end. And with that, we can also talk about the difference between a tuple and a list, because a list can be changed, but a tuple cannot be changed, meaning I couldn't append a value to a tuple. If I try that with a tuple and try to append a value, and then print a tuple afterward, although it's not going to work, we are getting an error that a tuple object has no attribute append. Python is basically saying that there's no way to append a value to a tuple. And if you want to make sure that your code is always working, just use a list. This one is much easier to work with, and in most cases, you can use either a list or a tuple, and your code would work perfectly fine. But anyway, for now, let's simply add a comment where we have the containers. Let's call it container setup. Actually, next up, we can work with a set. A set is defined with curly brackets, and there, once again, you can add whatever value you want. If I print the result a set, we get, once again, some kind of data structure. Now, what is really useful about a set is that every single value has to be unique, meaning if I add the 4 twice and run our code again, we are getting the same result. In some specific circumstances, this can be incredibly useful. As a matter of fact, sets for data analysis are really useful. There are quite a few methods where you can compare two sets and see which values they have in common or which are different, which can be an incredibly powerful feature in specific circumstances. Although in practice, how sets are being used is if you have a list or a tuple and you want to remove any duplicate value. What you could be doing is, let's say, for the list, I have the value 2 twice and I want to get rid of it, but I don't know at the moment which value is a duplicate. Just imagine that this list has a few thousand entries, and I don't want to manually look through it and see which value is a duplicate. To make that automatic, you can use the set function. This one takes any kind of container and turns it into a set. Let me actually print it twice. I want to print once the original list, and then I want to print it again after turning it into a set. So, set and then a list. If I now run the code again, we are getting, first of all, the list with all the original values that we have gotten up here, but once we are turning it into a set, we are getting rid of the 2 at the end and only keep the original values. And if you want to retain the list, you can wrap the result of the set once again into another function which is called list, which turns any kind of container into a list. So now, if I run it again, we have a list once again but without any duplicate value. In practice, when you see a set, this is what they're mostly used for. So, list, set, and then a list inside of it is a fairly common operation. Next up, we can work with a dictionary. This one is also defined by curly brackets, except now we don't have individual values. Instead, we have key-value pairs. Both the key and the value could be any kind of data type. For example, I could have a string that I can call key and then another string, which would be the value. I could also have a key called 123, and then the value could be a list with 1, 2, and 3. Both are totally fine. Let me print a result, a dictionary, and what we get is the key-value pairs of the dictionary. And once again, a dictionary can also be used with the lay function, for example, and there are a couple of specific methods that can make this one incredibly useful. But the main reason why you would use a dictionary is that you can address every single value is easily accessible once again. Imagine that you don't have key-value pairs, but rather something like 10,000 with a tuple or a list. You could only access values by the index number, so you could get the first, the second, or the third item. However, for a dictionary, you could always access a specific name, which is much easier to remember and work with, especially in specific circumstances. Anyway, these are the 4 major container types in Python that you have to be aware of. Although next, we will have to work with them a bit more. The part that I want to focus on is how to get values from a container. For that, we have to cover a little bit of theory. The process we have to learn about is called indexing. Basically, how it works is, imagine we have a list or a tuple with 5 entries. Internally, for Python, every single item is going to get an index. This starts at 0 and then increases by 1 for every single item. The first item has index 0, the second item index 1, the third item index 2, and so on. This behavior you can use by simply adding another set of square brackets after the container, and then you get one specific item returned. In this case, index 1 would give us pop, so this would be returned. This process can also become more powerful, and then it's called slicing. Once again, we have a list, which could also be a tuple, and we also have indexes. Imagine now you want to get multiple items. Let's say you want to get from Bob to Anna. For that, you could add square brackets with up to 3 values. The first item would be the start value, in our case index 1 would once again be Bob. The second number, so the 4, would be the end value, and it's really important, which can be very confusing. This 4 is only the value that we go up to, it is not included in our selection. Meaning, when you specify 4, you might think we are getting to John, but we are only moving up to this index, we are not including it. This is a source of many errors and, especially in the beginning, can be very confusing. This is very much something you want to practice on your own. But anyway, the third value, the 2 in my case, is the step size. By default, this is 1, we always go up by 1 number. However, if you specify a 2 here, you are going from 1 to steps to the next item, which would be index number 3. And well, that's the basics of how to get data from a container. Let's practice this one. Just to be a bit more consistent with the slides, let me create another variable, user list, which is going to be the list I just had in the slides, where we have 5 names. In your case, you could simply add the numbers in here, the logic is going to be the same. Also, I am going to comment out all the stuff we have done before so it doesn't get too confusing. Now, let me simply print the user list on its own. If I now run the code, we are getting the items inside of the list. That's a good start. But now, I want to add square brackets after this list where I can specify a number. This number could, for example, be 0. And if I run it again, we now get Lisa, which is item number 1 inside of the list. Since Python starts counting from 0, this would be the very first item, or item with index 0. If you change this 0 to a 1, we should get Bob, and we do. If we add a 2, then we are getting Alex, and so on. I hope the system makes sense. What you could also do is add a negative number. Let's say negative 1. In that case, we would get to John. The way this is working is that the first item is always index 0, and then minus 1 would be the last item, minus 2 would be 1 further to the left, and then so on. We are just going in the opposite direction. That's all that's happening in here, and that is indexing. To make this system more powerful, you could add 2 values in there. For example, I want to go from 0 to index 3. And what we are going to get now, if I run the code, we are getting Lisa, Bob, and Alex. Lisa has index 0, Bob 1, and Alex 2, and we specified that we want to go from 0, so this index up to index 3, but we did not want to include that index. And as a consequence, we get Lisa, Bob, and Alex. And if you want to expand that system, you can add another double colon and then specify the step size. For example, if you added 2 in here, we are starting with Lisa and then jumping 2 steps and going straight to Alex. I guess once again, Lisa has index 0, Bob is 1 and Alex is 2. And we told Python that we want to start on index 0, meaning on Lisa. Then we want to go up to the third index, meaning up to Anna but not included, and we only want to have every second item. So, we start with 0, then we skip 1 and go straight to 2, which would be Alex. Those are the values we get at the end. Slicing and indexing is an incredibly powerful system and something you definitely want to practice. Also, I should mention you can use slicing and indexing both with a list and with a tuple. If I replace the square brackets and turn this list into a tuple by using basic parentheses, if I now run the code again, we are getting the same outcome. The only difference now is we are getting a tuple returned instead of a list, but that's about it. Now, if you want to get the values from a dictionary, let me copy or rather uncomment the dictionary. You obviously couldn't use indexing on this one because we don't really have indexing. Instead, we have key-value pairs to work with. That means instead of using the index, we simply have to add, let me print a dictionary, you simply have to add the key that you want to work with. In fact, versus code is giving you a suggestion, it wants to have a key, and in this dictionary we have keys 1 to 3. So, if I put in 1 to 3, we should be getting this key-value pair. Or more specifically, if you are doing that, Python is returning the value associated with this key. Alrighty, and with that, we can get values from a container. Also, I realized I forgot to mention if you want to add a value to a dictionary, you can use a fairly similar system. So, let's say for this dictionary, we want to add one more value. For that, all you have to do is add square brackets once again, and then define a new keyword you want to create. Let's call it new_key, and then you want to assign a new value. Let's say 1.5, and then you have a new key-value pair. Python is creating this new entry automatically. So, at the end of it, you can print a dictionary again, run all of this, and before we are doing the other 2 entries, we are getting a new key inside of the dictionary. And this is all you need for the basics. And let me get rid of that because we don't really need it. To finish off this part, I want you guys to do an exercise. Create a list with the values from 1 to 10, and then use slicing to create a new list with the values 8, 6, 4, and 2 in this order. Pause the video now and try to figure this one out. Alright, back in the code. First of all, I want to get rid of this dictionary print, and then comment out the stuff I've just done. We don't need this one anymore. After that, I want to have a part for the exercise. And first of all, I will need an exercise list with the values from 1 to 10. So, let me simply type it quickly in there like so. And now, we have to use slicing to get the numbers from 8 to, I think I said 2. For that, I want to use print, and we want to get the exercise list and use slicing. We have to define a start value, an end value, and then a step size. This step size for this one is actually the easiest bit because we know we want to go in -2 steps. We are essentially jumping backwards by 2 indexes on every single item. Our start value should be 8 then, and our end value should be 2. Let's print all of that, and we are getting 9, 7, and 5. We are kind of getting in the right direction, but this is not right. And you might have spotted the error already. I have specified the start number as 8, but since Python starts counting from 0, this is not the correct number. And let me write all of them out, 0, 1, 2, 3, 4, 5, 6, and 7. These are the indexes, and you can see that index 8 is giving us the number 9, which is what we have gotten as the first value in our result. So, this we have to change. We don't want to have the number 8, we want to have the index 7. That way, if running all of this again, we get 8, 6, and 4. Although now we have an issue that we also want to have the 2 at the end, which at the moment is not the case because 2 is our end value. But remember, when we are specifying the end value, we are telling Python to go up to this value but not include it. In fact, what we can do is remove the value entirely. That way, Python is simply picking the lowest value, which in our case would be the start of the list. So, if I now run this again, we get 8, 6, 4, and 2, which is exactly what we wanted. And once again, especially in the beginning, slicing can be very confusing since you are starting to count from 0, not from 1, and you only always go up to the last item but not include it. There are lots of confusing parts in there, and this is just something you have to practice. Eventually, you will get used to it, but it's a bit of a journey, so be ready for that. But anyway, with that, we have learned about containers. If you like this lecture, please support India Moon channel.